All right, we're going to talk about Module 16.3, the area of a sector. So what I'd love you to be able to do is be able to kind of have a justification for why the area of the sector formula is the way it is, and then be able to calculate the area of a sector. All right. Okay, first, what is the area of a sector? So it's the shaded portion here, this part here, and it's the region that's bounded by this particular arc. So this arc here and the two radii. So that's what creates a sector of a circle. Okay, it's a portion of the circle. So if you were going to figure out, like how much that is, what's the area of that, it's definitely not the whole circle, right? But let's go ahead and just take the area of the whole circle. Remember, that's pi r squared. And it's not the whole circle. It's a fraction of the circle. So very similar to what we were doing before, where we said, hey, let's try to figure out the fraction of the circle when we were calculating arc length. We're going to do the same thing for the area of a sector. We're going to say, like, how much of 360 is it? And then we would say it's the measure of whatever that arc is. So the measure of, in this case, if it was AB, then it'd be the measure of AB. Sorry, that's a little bit messy there. I can make that a tiny bit nicer. So measure of AB, okay, and then times pi r squared. So that would get you the fraction of the circle. So again, it'll work if you have the measure of the arc, or if you have the central angle measure as well. If you knew that this was like, how much would that be? Let's say it was 100 degrees or something. You could also plug in 100 degrees right there and divide it by 360, and that will also, help you figure out the area of the sector. Okay? All right. Let's go to the next slide here. Okay, that's the same thing, just a little nicer. All right, let's go ahead and do this. So we're going to try to find the area of the sector ZOM. So that's this sector here, the one that's shaded. So it's going to be area equals, it's area of the sector equals. So area equals, and we're going to have whatever the arc measure is. So that's 72. So that's 72 over 360. And then it's times the area of the circle, which is pi, and the radius is shown there, so that's 20, and then we square it. So isn't that nice? It's just the area of the circle and then times whatever fraction of the circle we're trying to figure out. So then we just plug all that in, and it says leave it in terms of pi, so I'm going to go ahead and just type it all in. And I'm going to leave the pi out. So I'm going to do 72 divided by 360, and then times 20 squared. And I got 80, so then I know that it's going to be 80, and then it's pi. And then we do have units here, so because it's area, we know it's going to be square units. So it's going to be centimeters squared. Now again, the formula is nice that it works really well. If you were to put the units in there, because the radius is 20 centimeters, so if you squared that, of course, that's where you're getting your centimeters squared. So I just think it's really cool in math when the formulas always work to give you the correct units at the end if you plug in your units along the way. All right, next. And that's just a nicer version. All right, next one, we've got the area of this shaded sector is what we're trying to figure out. It's a lot that's shaded. It's practically the whole circle that's shaded, except for this little piece that's 45. So what we'll do is we'll do 360. We'll subtract out this little piece that we don't really want. And so that turns out to be 315. So that means all of this part that's shaded in yellow there is 315 degrees. Okay? So that's all 315 degrees. The radius is shown here. Well, the diameter is shown. So that means that the radius is just half of that. So it'd be 8 centimeters is what this part would be. All right, so let's go ahead and figure that out. So then this would be area equals and it would be what fraction of the circle this is. So the fraction of the circle would be 315 over 360, and then times the area of the circle. So pi times the radius, and then squared. This one says that it would like it rounded to the nearest tenth. So I'm going to say it's approximately, and then I'm going to go ahead and just type all these numbers in here. So 315 over 360, and then we're going to do times. I can go ahead and multiply by pi, and then times 8, and I'm going to square that. I got about 175 looks like 9, and then it looks like we're going to say it's centimeters squared again. Okay. Okay, that's a nicer version. Okay, this one, we've got 26 is listed again as the diameter. So let's go ahead and say that our radius would be 13 meters. And then it has this 120 listed. That's not the shaded region that we want. We can tell that this is the diameter. It's going through the center of the circle. So that means that all of this would be, this arc measure would be 180 degrees, or, you know, the central angle here would be 180 degrees. So that means if we want the shaded part, we know that would be pretty simple. It would just be 180 minus 120, and that would give us 60 degrees. So that means that this part here that we want is 60 degrees. So we want to just write our formula. So we're going to say area equals, we're going to write 60 divided by 360 because that's the fraction of the circle that we want. That is 1/6 of the circle if you reduce it. So that's the area we want. We want 1/6 of the area of the circle. So we're going to multiply that fraction times the area of the whole circle, which is pi. The radius is 13, and then squared. It says round to the nearest tenth again. So we're going to say area is approximately, and then we just type all that in. So 60 over 360 times pi times 13 squared. So I got about, let's see, I got 88.5, and that is meters squared. Again, if you put the meters in there, right there, it would be meters squared. And that is a nicer version of the same thing. All right. Lastly, I just want to kind of come back and compare the arc length and the area of the sector. So remember, the arc length deals with the circumference. You know, it's a part of the circumference of the circle. So again, you got your circle. The arc length is just, you know, a little piece that you're trying to find out. So that's why it makes sense that it's going to deal with it's going to deal with 2 pi r because it's the circumference, okay? But it's the fraction of the circle, so it's a part of the circle, so that's why it has this fraction in front of it. And so however you want to do it, if you want to say it's the measure of the arc of AB over 360 times 2 pi r. Then the area of the sector, really similarly, it's going to also have that fraction in front. So same fraction, it's going to be the measure of AB over 360. But remember, the area of a sector is like this region here, and it's a portion of the area of the circle. So that's why we have pi r squared to the right of that. So look at how similar they are. All they are is arc length deals with circumference, so it has the 2 pi r. Area of the sector is a fraction of the area of the circle, so that's the area of the circle. And then we just want, whatever fraction of the circle, and that's what goes right in front there. So that's how you can kind of make sense of them and see how they're similar, okay? Hopefully somebody loves you as much as this girl is loved by this guy. All right, have an awesome day today.